Okay, this is like a big program that you have just presented, Pat. So I was just going through it. Yes, Raj, this is a correct approach. What you have just mentioned is a correct approach. Okay, your mapper and reducer both code are correct only. If this is a problem statement, then what you have written is correct. You can do that way. All right. Okay, so today I'll be taking an example of Mapreduce on how do we process XML data. That was, I think, the ask for many people. They wanted to understand how do you process XML data, if you can take that example. So we are going to see that as well. So we have seen structured and unstructured data example. We will now see XML data example. This is also more like unstructured or semi-structured data. So let us understand that. So let's say this is my XML, which I'm going to process. Am I audible, everyone? Mary, are you able to hear me? Okay. Okay, fine. Because you said you are not able to hear, that's why I just wanted to check. So basically here what you need to do is, see, this is a XML example. Okay, now this can be a very big XML file or it can be a small, but ultimately the approach to solve an XML file remains the same. So you have this XML file and it has some property. Property is dfs.replication1 and the block size is, let's say, 128 MB. This is my property and I want to use this property. Okay, to solve some problem. Now let's say I want to do a very simple XML processing stuff, okay, which is something like this. You just use these two key values, okay. Well, basically from this XML file, just try to extract the right keys and values, and the output file, what you are going to write, you just write this dfs dot replication n1 dfs dot block size 128 MB. So what I'm saying is basically this is the output which you should be writing. Very simple. There is not much processing involved in this program. Okay. What I have to do is I have to just pass this XML in such a way that I can extract right key and value and write that as an output. Okay. This is the requirement I have. So let's say if you have this requirement, the problem becomes simpler in Mapreduce example where you don't need a reducer if you want this kind of output, right? Because you are just processing the data, parsing the XML file and just writing the corresponding key and value to the output file. You are not actually doing anything else other than that, right? That is what is an important task. So here, when you are just parsing every record and extracting keys and values and writing into the output, you just need a mapper class. You don't even need a reducer, right? Because there is no aggregation function that is required, right? So basically, it's called map only job. So in this problem, we are going to write a MapReduce without a reducer. You don't need a reducer, only mapper will be enough, right? The important point we need to observe here is how we are going to write our own custom input format class to process this XML file, and how do we use it. That is the important part. Okay. So is everyone clear with the problem statement, what we are going to do? Okay. So let us understand what exactly needs to be done to achieve that. Okay. See, the first important point is this is an XML file. It is not a normal text file. Okay. If it was a normal text file, then probably yes, you would have written so many things to solve that. For example, if I ask, let's say, if it was a normal text file, you would have directly written inbuilt input format class to basically process that text data and convert every record into key value, right? But here it is an XML file. Now here, if you just use a normal default input format class provided by Hadoop framework, then what happens? It will read every line in the XML file as one line, right? And then try to convert it into key value. But then it is very, very difficult here. If it reads every line as one line, then what first line will be configuration tag. What will it do with that? It will not be able to convert anything of that into key value, right? It's just a simple word configuration. So here in XML, unlike text file, you need to process it in a way where you need to take the entire record from start of one tag till the end of another tag, which I am highlighting here. Start of property to end of property becomes one record in XML file, and that should be given as an input to the mapper class. Similarly, there is another record which has a start and end of property tag. So that should be given as an input to the mapper function after this. So what I'm trying to highlight is it will have lot of such records, and each record will be actually given as an input to map function, right? But first of all, how to identify this record is an important thing, right? How to tell Hadoop that please take from property to the end of property tag as one record. Instead of just reading one line, please take this much portion as one record. This is the important part, and that is why you need to write your own custom input format class, which will know how to read this kind of data and then how to take one record from start and end of property tag. So that is the reason where we need a input format class. So let us see the input format class and we'll understand more on that stuff. So this will be my input format class, okay, which I have written. Now, one important thing that I want to highlight is so Mary, actually there are some binary data format which has a support like sequence input format, which is basically there in Hadoop. But then other than that, like if you have XML data or if you have a JSON kind of format, then yes, you need to write your own input format class. Okay. So here, XML input format class which we are going to write, okay, we have to understand it is basically a very huge, it is actually a very complex code that you need to write to generate a custom XML format class, okay. So you don't really need to understand everything here because it is really very complex, and we are overriding some inbuilt framework API itself from the Hadoop, which so that we would be able to write our own input format class. But right now you need to just understand some basic parts of it, which is the XML input format extends text input format. Okay, that is a base class for Hadoop. So it extends that class and it defines two properties, XML input.start and XML input.end. Start tag key and end tag key. What is that? That is nothing but between which record to which record I want to consider it as start and end thing, right? It's basically from which record to which record you want to consider it as a start and end tag. That is what it is defining here. So if you define start as property and end as slash property, then it will take all the values within these two tags as one record. Okay. So whatever I'm highlighting becomes one record in that case. Okay. After that, it will have a create record reader method. So the create record reader will basically have, so as I said, right, input format will have internally a method called create record reader, which will return a record reader. Okay. Now the record reader is a class which will do the job of converting your record into the keys and values. Okay. So it basically reads through the given XML document to output XML blocks as records as specified by the start and ending. So here there is a logic that we have written our own XML record reader class which extends record reader, and whatever I'm highlighting is actually all the code which is part of the XML record reader, which overrides certain APIs from the Hadoop framework. Like initialize is one, which takes one split, and basically it tries to convert entire split into start and end tag. So it tries to extract every record from between start and end tag that you have defined. Similarly, there are some next key values. Basically, it's all utility methods now, okay, that we have overridden here. So this is actually the code that you need to write to finally extract the correct record from between start and end tag. Okay, so in a custom XML input format class, what you need to do, you need to first extend it from text input format class, and after that you need to basically have a override a create record reader method where you need to write our own record reader class. In that record reader class, you need to override certain methods, right? Like record until match, or initialize, or next key value pair, something like that. So basically, it does a simple thing. It reads the entire XML document and extracts all the records which are between the start and end tag. So this is just an XML input format class that we have written, but how do you use it? So I have written one more program, one more class, which is a Mapreduce program. Okay. In that, in the driver code, as you can see, I am setting the property. I am saying that XML input dot start tag is a property and tag is a slash property. So here itself you are setting in the configuration object that what will be the start and end tag for every record in this document. After that you set all the other stuff, normal stuff, and then you are saying that yeah, you are setting the mapper class, then you are setting here. This statement says what is the input format class you want to use. That's it. That is the only difference. Other than that, everything else is the same. Okay. And here I have written a mapper class, which I will explain you. Before I go to the mapper class, is everyone clear as of now? Any questions? No, Raj, we don't have. No, Raghu, it is like little internal code actually. So as I said, it becomes very difficult. You need to debug the entire, you need to import the Hadoop source code and then debug it. Then you will understand, what is happening inside each and every method, right? So just by adding statements will not help. Yes, Mary, yes, that's right. Yes, Mary. So this XML input format class that we have written, right? It doesn't need to be changed for any XML. Just the start and end tag will change based on what you want to consider as one record. Till which point to which point. So here in the driver code of your Mapreduce program, you need to change that. Okay. This is the code, Olga. Yeah, Olga, you wanted to say something? You had some question, or you just wanted to look at the code? Okay, fine. All right. So yeah, that is about driver code. Now we need to do is we need to basically generate. We need to write a myMapper class, which extends a mapper class. Okay. In the Mapreduce program, for example, see what happens here is it it would have basically extracted this much portion as one record and this much portion as another record, right? So basically, once you have this portion as one record, after that, you can actually use it in the map function to process it. It's just like this. Your one value object will contain the entire record, which is a XML data, right? From here to here, this becomes one value object. Byte offset will be the same. Byte offset will be the starting point of this property tag, which is a key. But the value will be this XML, mini XML. So here, this is a byte offset, this is a mini XML and the context object. Okay. And what you are going to do here? So see, once you get this right? So once you get this value, right, which is a mini XML between property to and property tags, you are creating a one string out of it, and then you are printing that string. Now, what you do with the logic? It's basically simple. You have a XML, right? See, now the idea is you get this record. Now custom input format class has done its job and it has given us one record between property to and property tag. Once we get that record, that XML as a mini XML as part of the value in the as an input value to the map function, we need to use some APIs to basically process this data and extract this as a key, this as a value. So now it is a simple problem, a simple Java program, which is nothing but you need to use some XML parsing APIs. There are some XML readers available. You need to use that so that you can extract corresponding key and value from the property tag, right? Corresponding key and value from the property tag. So basically, you need to use a code which extracts corresponding key and value here. So as you can see here, I am using XML stream reader. It's basically nothing but it's a Java API, okay? Java XML stream APIs. So that is what I'm going to use, which basically know how to read an XML, and then I will go through reader.next. Next means each record. So it will only have first one record, which is a start property to end property. And then here you are defining that if it is a start element, do this. If it is otherwise, get all the values. Okay. So between properties, this and this portion, this is called characters. These are the actual value of this tag, right? So you come here. In this particular portion, you are again checking if a current element is name, then you extract the value for the property. So basically, if it is name, I want to extract this data, which is nothing but this is how you do it. Reader.getText will give you the data. If it is value, again reader.getText will actually give you this value. Okay. So I'm setting it into two different variables, property name and property value. Alright. And then finally what I'm doing, context.write property name and property value, which is what I'm writing it from the mapper. So every record that I'm going to process, which starts with property and ends with property tag, I'll use the actual value of the name and value tag, and then that is what I'm going to write it as an output file. Okay. So again, for the next record also the same thing would happen. Map function gets called and it will extract this as a key, this as a value, and write it as an output file from the mapper. So this is how you basically parse an XML using custom input format class. So is everyone clear with this code, mapper code? Any questions on this? So it comes here, Olga, and basically, see, it says reader.hasNext, which means it reads all the values between these two tags, property.property. This is one record. Under that, when it comes here, it will check if it is a characters. What is a characters? Character, see, you need to understand some XML API. So a character means the values within the tag. So between property to end property, whatever is the data, that becomes characters. So you get this data. Okay. Under that, now you are checking again. If it is name, then extract the name characters. If it is value tag, extract the value character and set it into the respective strings, respective attributes. Okay. So basically what it does is it just takes this name and extracts the characters of this name tag, and it takes value and extracts this value from this tag. Okay. So basically XML stream reader, what it does, it will take this entire record and then try to extract each and every record from this, each and every character from this tag. First it has taken these two data as the characters, and once you come inside this case, which is character case, now you are extracting basically a name tag. Okay. And under name tag, whatever are the characters, you are setting it as a property name. Under value tag, whatever are the characters, you are setting it as a property value. That is what you do. That's the simple logic that is being followed here. You go to reader to next will give you the next tag. It's like this. It is internally iterating to each and every tag. When you say reader, it's a XML reader. Dot next means every like within this tag, whatever is the value that it returns. Again inside that, if you do dot next, it will return first tag. In that you read this particular character and then go to the next. Okay. I know it is little difficult to understand if you're looking for any XML code for the first time, but then this is how it does. So you need to put little more effort even after this to kind of understand the XML file. Yes, Vishal, that's right. So start element, Mary, is a start element for this tag, right? Always it will start with property. Then you say reader.next. Again, it will come to name. It will also start element. This is the end element, right? So for every tag there is a start and end. So start element means this. After that, when you do reader.next, it will give you this portion, and then you read that data. Okay. No, Raj, that's what I'm saying. So you don't really need to write input format class again and again for every XML. XML input format can be written only once. The key point here is, which is this property and slash property, which you are defining in the driver code, right? You are telling the framework that this is the start and end tag. So in the next XML, let's say you may have something like, slash Raj and, Raj and slash Raj. Let's say you have defined Raj as one tag and end tag is also Raj. So all the values within that tag becomes your one record. Simple. So you don't really need to modify your input format class again and again. You just need to set start and end tag here, based on which it will give you the entire record between that two tags. Okay. This is the start element code, Olga. Okay. You get the start tag. You don't really need to worry about end tag. End tag doesn't matter here. Just get the start tag, and once you have that object, you are doing dot next dot get text, which will give you the value for that. So Raj, is it clear? Your question is clear? Raj, are you there? Okay, let me know when if you have any more questions. I'm sure your question should be clear, what you have asked. Vishal, are you clear? Mary, you have asked these questions, right? All right. So let me execute this code and show you how does it work. So execution is very simple, just like a normal Mapreduce that we have been doing. I'll just export it as a jar. And I'll have to use that Hadoop jar. I have to use the XML class, and then I'll just say, okay, I think I have not put the data. First, let me copy the data in SDFS.
All right, so we have copied the data. Now we need to execute the jar file. Raj, as I said, right, you don't need to change the XML input format class unless and until you are processing the XML file. That doesn't really need to change because this code that we have written will know how to process, how to extract a particular record data from start and end tag. So it is a generic code. You don't need to change that. That's what I was telling earlier also. You just need to supply right key and value right start tag and end tag property in your driver code. If you are changing the format, apart from XML, let's say you are using now JSON file, then you need a different input format class, right? So input format class are just written once, which will know how to process that structure of the data and extract a particular record from there. That is the input format. So it doesn't need to be changed again and again, right? Even if you use any complex XML. So I'm going to execute this code. I think I have not done one thing, which is yes, that's right. So we are executing this code now. That is a base class married to write any output into the text format. That's a base class. You can say it's a super class basically for output format. So tomorrow if you want to write any custom output format class, you need to extend it from text output format. Otherwise, by default, it will use a text output format whenever you want to write output into the SDFS. It will be in the form of text. Okay, so it has generated the output. We can now directly go and read the data inside the output. So as you can see, this is the output we got. We extracted correct key and value respectively from this XML file, right? So that's how we can work with just XML kind of files. Okay, is that clear, everyone? Any questions? You need to tell me that, Mary. After learning the entire MapReduce, this question should not come. Why output is in reverse order? Just think about it. What does it do? How many phases are there? Map, shuffle and sort, and reduce. Now, can you get some hint based on that? What it has done with this output? It is nothing but sorting all the data based on the keys. Yes, Raj, that's correct. Okay, Mary, is it clear? So you're sorting the output based on the keys and then prints. So this completes the entire MapReduce, by the way. We have seen various flavors of MapReduce, in fact much more than what normally people cover in the training. So I hope you have understood all of them, and I'm sure you are also parallelly doing some practice as well. I've shared all the code yesterday itself. So please keep practicing on that. And any more questions you have regarding MapReduce before I jump on to another topic? All right. So now let me open a new topic, which is, so we have covered the advanced MapReduce as well, and of course advanced SDFS that we have covered earlier during that SDFS session. So now we are moving on to the next topic, which is an ecosystem component of Hadoop. Okay, basically it is like, all this like pig, hive, HBase, scoop, flume. That is what we are going to understand now. All right. So let me just open and share this document. We will start talking about it. So we will start understanding about pig now. Okay. So our core Hadoop is done. Okay. And remember, we have also covered YARN architecture. So core Hadoop, which covers the SDFS and MapReduce extensively with practicals, and we have also covered YARN architecture and what is the advantage of using YARN. So this completes your core Hadoop. Okay. Now we will start with ecosystem component of Hadoop. where we'll start with pig. As I said, pig, hive, HBase, scoop, and flume. These are the most important ecosystem components that we want to understand. We will also do some practicals in each of them. Okay. So let's start with pig. All right. So let's understand the pig motivation. Why pig needs to be developed? So earlier, as we understood, there was only Mapreduce and SDFS, and people used to write when they used to store data in SDFS, if they want to analyze the data, they have to rely on Mapreduce. So basically, that was the only way to process the data stored on SDFS. There was no other way, right? So people used to write, either Mapreduce programs to process the data in SDFS, or they couldn't do anything else basically. So let's say there are some people who are business analysts or data analysts in your company, and they want to also analyze your data stored on SDFS. In that case, what happens? In that case, they will not be able to do they will not basically do anything, right? Because they don't really have skills to write Mapreduce programs. Either they need to learn that and then do it, or they need to rely on someone else who can help them achieve that, right? Who will be an engineer and who can basically write that programs and execute and generate the output for them. Now, this is a kind of a limitation which was seen by a lot of companies, and Facebook has seen these limitations, that why to always depend on Mapreduce, why to always learn Mapreduce to process data on SDFS. Is there a way where I can actually avoid this step of learning Mapreduce and I can still process data stored in SDFS? So Facebook has come up with a component called Hive, which is now an open source. So they have come up with this component where they wanted to basically allow people to analyze any structured data in SDFS. Okay. Remember one thing, for Hive, it is just structured data. Similarly, Yahoo has come up with a pig here. Pig is developed by Yahoo, and they also had the same motivation, but they have come up with a component where they can allow it to analyze structured and unstructured both. Okay. So again, Pig or Yahoo basically expect people not to learn MapReduce, but you need to still write your analysis logic using one scripting language called Pig script. Okay, it's actually the name of the Pig scripting language is basically called Pig Latin. So we need to use that portion. Pig Latin. This is the scripting language. This is what we need to use. Okay. So I'll again repeat. Basically, instead of learning MapReduce, any person who wants to analyze the data on SDFS can just learn pig-Latin scripts, which is much more easier language to learn, which is very developer friendly, and you basically write your analysis logic in that language, which will internally be converted into Mapreduce program by Yes, Mary, absolutely right. That is what I meant actually. So, in fact, people who don't want to learn Java can use these components to work with Hadoop actually. You can learn pig scripts and then you can start processing data. But only challenge is, of course, these scripts are not very powerful scripts which can help you to solve every problem under the sun, right? You need to also definitely make use of Java kind of languages to solve such problems. So even in Pig also you can call Java, I mean the code written in Java, and that is called Pig UDF. I'll show you that also, right? So obviously it is not going anywhere, but then definitely for people who are not hardcore programmers or who have not had done any coding in Java, this is a good option. Okay. So this is one of the component which is developed by Yahoo, and again internally Pig engine will be there who will convert your Pig scripts, Pig Latin scripts into the Mapreduce program. So it first compiles your script, validates your script, create an execution plan, and then generate a Mapreduce, and then optimize it to execute it on the Hadoop cluster. So basically all the ecosystem components, specifically Hive and Pig, does these things where there is a dedicated engine, Hive engine and Pig engine available, which takes your queries, convert it into MapReduce, and then execute it on the Hadoop cluster to process the data and give you the result back. But everything happened behind the scenes. The user is not aware of that. So even if we are a Pig developer, we don't really need to worry about what is actually happening behind the scenes. You can always read about it, but then it is actually completely transparent, right? So you just get the requested output and you are fine with that. By the way, am I audible, everyone? Okay. Yeah, because I was just answering one question, so looks like some portion I didn't get any response. Okay, let me repeat. So, Mano, this is to answer your question. Uh, why do we need to use Mapreduce other than if we have such tools available? So again, as I said, right, Mapreduce people prefer because it gives you more flexibility in terms of handling complex requirements. Okay, so it is actually something like this where you don't why. So by the way, everyone, Mano's question is why do we need to use Mapreduce if we have these tools available? So the answer is, first thing is, see, we are writing native Mapreduce program and executing on the cluster. So performance-wise, it is definitely better than writing Hive or Pixscript because they are internally converted first into Mapreduce and then executed. So we are avoiding that step, and that's why performance-wise it is better. Second thing is, if you, I mean, if you are a Java expert, then definitely you will love writing Mapreduce program. Why? Because it will give you a lot of flexibility in terms of programming, right? And this any developer can easily understand what do you mean by flexibility in programming. So you may have a lot of complex problems that you need to solve, and that can only be done if you have a right language, programming language to work on, right? All Hive is just an SQL, or pig scripts are basically piglet scripts, which may not have, let's say, all the support where you can solve some complex problems by importing third party libraries and so on and so forth. That's why Mapreduce is still a very very reliable way of writing programs. Yeah, but only for people who know Java. I mean, there are people who doesn't know Java and who don't want to learn Java, so maybe then this is a better option for them. Is that clear, Mano? Yes, Mano. So as I said, everyone, MapReduce main advantage is performance over Pig and High. MapReduce is faster. Second thing is MapReduce gives you better control in programming. These are the two reasons, okay? Based on which you can choose that. But as I said, it involves a lot of complex Java programming, whereas Pig and Hive is much more simplified tools which simplify a lot of stuff in programming. So 10 lines of Pig code is equal to 200 lines of MapReduce code. That's the kind of advantage you get when you start writing code in Pig, right? So you can extract a lot of complexities, a lot of inbuilt functions are available. You can directly use it. But the same thing if you want to do in MapReduce, you have to write some programs. Swaraj, so basically, big limitations are there. Some of them are there, but then, as I said, it doesn't really support extensive third-party libraries. So some of the functionalities, if you want to solve using Pig scripts, you can't do it because there is no third-party library support available for that. So in that case, you have to rely on again MapReduce or Java. So sometimes what happens is people write that piece of code in Java and then call it in Pig. That is also possible. So pig has that option available where you can write some portion of your logic in Java and then call that in your pig scripts. No, Mary, output will be the same. Output cannot be different. Otherwise, there is no point in using these technologies, right? So the output have to be the same. Yeah, Vishal. So when I say pig is easy to maintain because it actually contains a language, it is a scripting language, as I said, which is nothing but, that's what I said, 10 lines of pig is equal to 200 lines of Java. So you can easily understand that you can achieve a functionality by writing fewer lines of code. When you have fewer lines of code, it becomes easy to maintain that code and extend that code, right? Understood? Okay, so it's a high-level data flow scripting language. It runs on Hadoop clusters. It is an Apache open source project, and of course, it uses HDFS for storing and retrieving data, and Hadoop for Hadoop Mapreduce for processing the data. So Piglet in language, it's a procedural data flow language. It contains syntax and commands that can be applied to implement business logic, example, load, store, etc. We will see all these commands in different examples. Okay. There is a runtime engine, or we call it as Pig engine itself. What does it do? So it compiler basically it is a compiler that produces sequence of Mapreduce program. So what it does is, when you are submitting a Mapreduce program, it will internally go through this compiler, and when you submit pig scripts, it will go through the compiler. First, it will check your scripts and it will validate that. After that, it will basically compile and then try to understand if we can, live with that compiler. So it's something like this. So let's say you are writing a pig script. It will first check the validation for that script. Then it generates a query plan, generates a MapReduce equivalent for that. Once it generates that MapReduce program, then it will execute it. So it may be possible that for the one pig script, there may be multiple MapReduce programs generated which are basically nested, right? It is called chaining of MapReduce, where output of one MapReduce job will go to the input of another MapReduce job. So that is why it says that compiler that produce sequence of MapReduce programs. It uses HDFS for storing and retrieving data. It used to, interact with Hadoop system. Part6 validates and compiles the script operation into Mapreduce, which we have already seen. So that is the job of pig engine, which is called runtime engine. So this is a simple three-stage operation: load data and write pig script. So as you can see from this slide, we are just basically writing the pig scripts in this fashion, and what it does internally. So internally, it parses the script, checks the script, optimizes the script, plans the execution, submit it to Hadoop, monitors the job progress. Okay, this is what happens, which we have already done. This is the activity done by pig engine, and it generates a map and reduce to execute the data. Okay. Now, in pig is also just like, data flow language, which is basically referred it as, you can actually work like the same way which you work on RDBMS, like you have tables and rows and columns. Here also you have similar concept. So in pig, any table in RDBMS, if you have a table, let's say in RDBMS, that thing is referred as a bag in pig. We call it as bag. Okay. Any table is a bag, and you may have columns, you may have rows. So every row in a table is called tuple. Okay. And then you have atom. Atom means every row and column intersection. So for example, this is column 1, this is row. This is the cell value, right? This is the value for every row column intersection, that particular cell value, which is called atom. Then map is nothing but every column in this bag will be stored in the form of key values pair. So it is like, name is a column, mic is a value, phone is a column, this is the value. So every key value pair, every column will be stored in the form of keys and values. That is why it is a map kind of data structure. Okay. So these are just some terminologies which are frequently used in Pig. That's why I have just explained that. Okay. Now we will talk about different execution mode in Pig. I'm sorry, Mary, I didn't get your question. Can you repeat it? What you are trying to ask? Pig, is there any explanation? So, is there any expansion? I'm still not sure, but then if you're asking about a script extension, then it is .pig. Any script that you write for pig, it will be named as .pig. I mean, at the end, the extension will be .pig. All right. Anyway, so there are two different execution modes in Pig. You can actually basically log into local or Mapreduce mode. So why do you have two modes, first of all? So when you log into, let's say, local mode, you can actually execute every entire Pig script as a Mapreduce, but then it will be executed as a single JVM process. For example, we know, right, in a Mapreduce you have Mapreduce all this phase. So it will be something like this. For example, if you are running a local mode, if you are executing a local mode, then what happens? You will have a single machine where in a single JVM, all your map task and reduce task will be running, right? So it is not actually a distributed execution. It is as good as running a single Java program on the local machine. And in the local mode, what happens when you're writing a Pig script? It would process the data. The data will be stored in the local file system only, not in SDFS. And the output also, it will generate it in the local file system only, not in SDFS. Okay. So that is what we mean by local mode. Local mode means it will not generate any output on the SDFS. Everything will be written in the local file system. So Pig will have two different modes of execution. One is local mode, which we just discussed, and one is Mapreduce mode. That is a production-like environment where it is a typical distributed environment where you submit your Pig scripts, and then by logging into Mapreduce mode, so it will execute it as a normal Mapreduce program that we have seen earlier also. It is a complete distributed processing. But in that case, the input and output data should be there in the SDFS, not in local file system, when you log into the Mapreduce mode. Okay, so how do you log into the local mode? You will say pig-x local and the script name .pig. Okay, so pig-x local will tell you whether it is allowing you to log into the local mode or different mode. A pig, normal pig, if you write, then it will take you to the distributed mode, or you can also say pig-x mapred. When you execute this command, it will think that you are basically executing see, it's like this: pig-x local means local mode, pig-x mapred means mapred mode. Simple, right? So either you just type pig and enter, or you just type everything like this and then say mapred. Both are the same thing. Both will take you to the Mapreduce mode. Okay, and as we discussed, in the local mode, everything runs as a single Java JVM process, and your input data which you want to process using pig script have to be there in local file system, and the output that it writes will also be written into the local file system. Whereas in Mapreduce mode, input and output will be there in the SDFS. So is that clear about these two modes? Yes, Olga, that's right. So developers will use local mode for quickly testing out their pig scripts, and then they deploy it in Mapreduce mode for production. Yeah, anybody has any more further questions on local and Mapred mode before I move forward? All right. So now you have two different interactive modes here. What is an interactive mode? So there is basically two different ways you can execute your pig scripts. One is interactive mode, one is batch mode. Right? Interactive mode means more like an ad hoc analysis. So you need to log into the grunt shell, right? I will explain you how to log into the grunt shell. But there is a shell of pig under which you can write all the pig commands. It will execute it one by one. So if you have a requirement where you need to basically do a lot of ad hoc analysis in pig, you can use interactive mode, where you log into that particular shell, and then you can execute every pig scripts one by one. As you can see here, this is one pig command or statement. So you are executing it, and then you can generate an output also by pressing dump command or store command. We will anyway learn about them as well. And then the batch mode. Batch mode means, see, when you type pig and the script name, it will basically execute entire script as one batch mode script. Okay. So what you do is, instead of writing all the statements on an interactive mode one by one, you basically write everything and bundle them together as one file, and you just execute that file. That is called batch mode. Okay. We'll see the examples for both of them. Okay. So There is a comparison given between Pig and SQL. So Pig is a scripting language used to interact with HDFS. SQL is a query language used to interact with database. Pig is a step-by-step execution. SQL is a single block. Pig is the lazy evaluation. I'll explain what does that mean. And SQL is immediate evaluation. Okay, Pig pipeline splits are supported. Requires the join to be run twice or materialize as an intermediate result. So Pig anyway does Mapreduce execution, so that's why it has this support. So let us understand one problem and let us see how we can write a Pig script for that and how do we have an equivalent SQL query for that. Okay, so that will really give us sort of understanding. So let us understand the problem. What is the problem statement? I want to track all the customers in Texas who spend more than $2,000. That's the problem statement. Okay. I'll again repeat, track all the customers in Texas who spend more than $2,000. Okay, now how do you write that query in SQL? You'll just select customer ID, then take the total sum of amount as total from the customers, join with sales on the customer ID, where city is Texas, order by customer ID, group by customer ID, and then order by the C total descending. So it will print all the customers who are spending more than 2,000 in the descending way. Whoever is spending more will be printed first, then less, then less. Likewise, I'll be basically solving this problem of finding all the customers in Texas who spend more than $2,000. So it's a simple SQL query, and I'm sure everyone knows how to write SQL for these kind of problems. Anybody has any doubt understanding this SQL query? All right. So let us move forward. So how do you convert this equivalently into the Pig script? So in the Pig script, as I said, it's a step-by-step execution of the query. Okay. So you don't really write everything as one function and all that. Here it's just different steps which executes one after another. That is what Pig script looks like. Okay. So let us understand each step here. First step is, as I said, right? See, you want to find out all the customers who spend more than $2,000 who live in Texas. So I have a customer data in some file. So what I will do, load that data, load data from this file as one structure, customer name, city, customer ID. Okay, you can also define a data type here when you are loading it into some bag. This is called creating a bag, okay, or creating a table in pig. Right, so basically this statements, what it does, it will read one file and then load that file into this kind of structure which has 3 columns and give the name of that bag as customer. Okay, so what happens here, I will have one bag which is created, for example something like this. I will have one customer table created which has a customer ID, name and city. This is what has been created internally. Right? Now, same thing, there is the sales data because you want to find out how much money he has spent and all that. So, sales data you want to load it into separate table. So, you are also loading one more table called sales, and it will have a sales ID, a customer ID, and amount. Nikhil, this is actually in-memory data. You are not really creating a table, but you can visualize it this way so that you can understand it better. It will just materialize everything as a Mapreduce program only. So there is no actual physical table which is created. So you can say it's a virtual data, virtual bag. So you have customer and sales, 2 tables created. Now what you need to do, you just say filter. See, I am just solving the problem which is already there in the earlier in the SQL. I mean the same function we want to solve, the same use case I want to solve. Okay, track all the customers in Texas who spend more than $2,000. That is what we are doing here. Now the third, once we have these 2 tables populated, what do you need to do? Right, so you need to basically filter out customers by city is equal to Texas. That is what you want, right? So from here I'll create one more table, okay, which is basically a sale Texas or something like this, which just has data of the customers which will have of course a fewer records, but it has only the Texas related information. Okay, I think this is not salary, this is city. Yeah, and here it will be Texas only everywhere because I have filtered out those records, right? So you have created one more bag. This is called creating one more bag from the original bag which is customer. So I have created one more table. Then what you need to do, join customer by CID, sales tax by CID. Actually it is wrong. It is not join customer, it is basically join sales. This is some typo in this material. Sales is a table. So you want to join these 2 tables, the sales and the Texas table which you have created, which just has customer data who lives in Texas city. So I want to join these 2 tables which has a customer ID as a primary key foreign key relationship, you can say, right? So you are saying join sales by CID. CID is a column in sales table, and sales tax by CID. Sales tax will also have a customer ID column. It will create a Once you join this, it will create a new table, right, which is a join table, which will of course has all this data, both this data, customer ID, name, city, and here you have date and amount. After that, you want to group that table by CID. So I want to group all the customers IDs, all ones to be together, all two to be together. It's like it's like grouping by CID. That is what I'm doing, which I'm generated as one more table called group. So it will create one more table called group, right, which will have that data. And then what I'm doing for each group, so for every record in that group, I'm basically counting the sum of amount, right? So for all the customer ID, see, it's like this. Customer 1 would have done 3-4 transactions. He has purchased, he has made 3-4 orders. So I want to check whether the total count is 4 or 3. So that's where I'm doing this sum of amount, total amount that he has spent on doing this, right? So that is a sum table. And from there, you are saying filter sum table by $1 greater than 2000, which means, see, I want to find out who has spent more than 2000. So I got a total count of amount spent for every customer. And from there, I want to now filter out only those records which says the amount is greater than 2000. $1 means it's a second column actually. First column will be $0. It will create a new table, and that spender you can order by, let's say, $1 descending, which means you are actually still ordering it in a descending order. Okay. And once you do that, you just say dump sorted. Dump sorted is a command to basically print the output on the console. Simple. Okay. Now, important point to notice is all these steps which I am highlighting here, all these steps which I am just now drawing a box, it is just a simple step. There is no execution that happens. Okay. This is just a simple plain vanilla steps. When you execute dump or store command, at that time only pig will actually start taking all these steps and generate a equivalent Mapreduce program and execute it on the Hadoop cluster. What does that mean? That means it's a lazy evaluation. It doesn't get executed until and unless it is required. So when you start executing it as a Mapreduce, it should start based on that. Okay, so that is why it means a lazy evaluation. So is everyone clear as of now? Any doubts on this pig script that we have written here? So Nikhil, as I said, right, there was some typo. It should be sales, not sales BLR. Sales. This is not sales BLR. This should be sales Texas. These two places it needs to change in the material, in the PPT. Okay. So is everyone clear with this script that I have explained? Any doubts on this? So Raj, just understand, as I said, this is a lazy evaluation. There is no need of having more memory because it doesn't execute any operation. It just remembers these steps, that these are the steps I need to create. When you execute dump or store, then only it will start executing it as a Mapreduce. So there is no point in storing data in memory. Is that clear? It will be a normal Mapreduce. Raj, that is a different question. We can't cover Spark and Pig here. Okay? We'll talk about Spark later, but then even Spark, we will not cover it in this training. So that question I would not be able to take up right now. Olga, it is two files, yes, but then you can see that this customer table, I am filtering out based on CTS Texas, and I'm creating new table called sales Texas. I'll be using sales Texas and sales. These two tables I'm joining. This is where you are making use of both. This answers your question also, right? Okay. Yes. Any further doubts on this query? Yes, Raj, I know I got your point, but Spark is actually, we really need to understand the entire framework and architecture. Otherwise, it will be not really very clear to understand that answer. Right? So Spark does lazy evaluation, Pig also does lazy evaluation, but the way Spark handles the execution and the data storage in memory is in the form of RDDs. So there are a lot of concepts we need to be aware of before we get into Spark. So let's leave that part aside. Okay? It's not a right forum to discuss that. Yes. Any further questions on this topic? All right. Great. So this is one simple pig script that we have written. Now there is a step given to install the pig here. It's like in case if you want to install it in a normal Ubuntu kind of server, all the steps are given. 5 steps are there, basic steps, and you are done with pig settings. It's just that you need to basically download one pig tar file, untar it, and set one path. That's it, done. Right? But anyway, in the Cloudera VM, it is already available, so we don't really need to worry about setting it up. So what we will do is, after this, we will start with the practicals on pig. Okay. So we will understand how to write different pig scripts, how to solve some problems using pig. So we can take a break now, and once we come back after the break, we will do some practicals, hands-on session. All right. So see you all after the break. We'll take a break now and we'll come back and we'll continue further. Yeah. So see you all after the break. All right, so we'll start with the practicals now. All right, so for pig, right, we understood that there are two ways we can log into. One is local mode, one is Mapreduce mode. So let us understand first how do you log into these two modes. So you'll just say pig and just type enter. It will basically take you to the grunt shell. Okay, this is the distributed mode. Okay, as you can see here, it's basically a distributed mode where you are logged into the grunt shell. Now, how do you say that it's a distributed mode? So the main difference is this. It says connecting to HDFS file system at this particular URL, which means it is connected to HDFS Quickstart Cloudera 8020. Basically, this is the URL where it is connected, and it is nothing but it's an HDFS URL. Hence, it is called a Mapreduce mode or a distributed mode. So this is how you can log into distributed mode using pig. If you quit, it will come out of grunt shell. Okay. There is also one more way to log into the Mapreduce mode or distributed mode, which is pig-x mapred. If you type that, it will still take you to the same distributed mode, right? And then you can do all your operations like that. So we will again see how does it, take us to that. Hello guys, can you hear me? Yeah. So did you understand? I don't type grunt, Olga. So see, for example, I'm just typing pig-x mapred. It will take me to the grunt shell, right? In grunt shell, you will be writing all the pig scripts. I'll explain you how to write a pig scripts in the grunt shell, right? So that is what happens. We are just connected to the grunt shell by typing pig this command, and it will decide which mode you want to log into, distributed mode or local mode. Okay, so this is my grunt shell. Here I can start typing some commands, or I can just say quit if I want to come out of grunt mode. All right, that is what I have done. Now how do you log into local mode? So you just say pig-x local. When you do this, it will take you to the local mode. Okay. Now here what happens is it will say it is connecting to system, but this is the URL. It is a file colon slash slash slash, which means it's a local file system. It is not SDFS. Okay. This will be a local file system URL. That is what it means by connecting to local file system, local mode. All right. No, it does not show that. Okay. Now let us start understanding about some pig scripts. We'll start writing some pig scripts. So first of all, let us understand that I'll be writing one pig script where I'll just take a very simple case study. Let's say I have a set of, I have, let's say, a bank, and a bank has two branches. One is in India, one is in US, and it will have certain customers, right? So bank has already found the credit score of each and every customers from both India and US branch, right? And it has generated them into two different files. Okay. What we need to do is we need to basically find out what are the customers who has credit score more than 5 and what are the customers who have credit score less than 5. For example, let us see the first input data. So let's say there is a customer India file which has username, city and the credit score. Similarly, there is a customer US file which has username, city and credit score. Okay, so I want to see these are the records in US file. There are other records in India file. We have two files. So it has two branches. That's why two files generated with each of their customers' credit scores. What we need to do is we need to use some page scripts to kind of merge all this data and then find out how many customers in both India and US have considering basically both the files, how many customers will have credit score more than 5, how many will have less than 5, and just separate them into two different reports, right? Based on that, I will find out that, okay, some customers who have good credit score, I can give them some privileged services. Some who have not, I may not be able to give them the good privileged services. So that is the problem statement we are trying to solve. Is everyone clear with problem statement? Okay, so let us start working on that. So these are the two files I have, and I have connected to the local mode, which means I need a data from the local file system. I'll also show you how to process data from distributed mode in one more example. But right now I'm in a local mode, so I need to give this path. So what I'll do, let me load some India file, okay? I'll just say load. You can give the path of the file. Now here the important point is, see, you are giving the location of the input data which you want to load it into one table in pig, right? Also, one more important thing is this file will have a separator as a column separator as comma, right? It has 3 columns separated by comma. So you need to inform pig that what is the column separator. This is how you do it. Using pig storage, comma, okay, as let's say user name, city, score. Okay. So this is what you do it. Basically what happens here is you just say load that customer India file using pig storage comma as this. Okay. And after that you just execute it. So it would execute it as it will basically execute everything into the India. See what happens here is you are trying to parse a file, you are trying to read a file and trying to load it into a table which has 3 columns. Here I am also showing you the data type of the column. The char array will represent string, right? Integer is integer. So basically I'm going to load all the 3 columns of this file into these 3 columns of the table which is and whose name I'm giving it as India, because I'm loading India file, right? And you are also telling the comma separator is the separator between different columns in the file. So pig can easily identify value of each column from the file and assign it to the respective tables. Okay. So this is one statement. Now, how do you know whether this statement is working as expected or not? You have written this, fine, but then how do you know if there is any error, or how do you know whether it will work as expected? So basically for that, you need to actually, there is a beautiful command available in Pig which helps you to debug that. It says illustrate India. Basically, illustrate is a command through which you can in fact debug your pig statements and find out how it has performed in the last run. Okay, so if I do this, right, illustrate India, what does it do? It will take one sample record. Remember one thing, it will just take one sample record from this file and it will tell how I would load this record in this table, right? Let me show you this. I'll just type illustrate India. So it will just take one sample record and then explain you how does it process that record using that step. So as you can see, it says that yes, this is the table I'm going to create with these 3 columns and this is how your record will be divided, right? So which is exactly what we want, right? This is how we want it to be divided. So our step is working fine as expected. If you do illustrate one more time, then data will change. See, earlier it was Mumbai, now it is Bangalore, right? So it will just randomly picks up any record and then tries to load it into the table. It is not actually generating any execution or Mapreduce here. It is just doing sampling. Just take sample record and try to explain you how would it load it here. So is that clear, everyone? How to usually illustrate? Now let us do the same thing for USA. We want to load a USA customer file also. We'll just say load customer US using No, Olga, you can do illustrate on anything actually. Now I'm doing illustrate on USA just to check how USA file is loaded. So it is also saying that it has taken a sample record and this is how it would load. So we are good. We are good there. We don't really need to worry about anything. Our two steps are working fine. So are we clear on these two steps? Any questions till these two steps? Yes, Raj. It is actually a natural question to have. Does it really physically store this data which we are seeing? The answer is no. Okay. All the steps that you are executing, by the way, are basically just it is just remembering these steps. It is not executing it. Remember lazy evaluation we talked about? Until and unless you execute dump or store command, it doesn't really execute these steps. So in that case, they will be stored somewhere, and then when you do the the dump command or when you execute it, then yeah, sorry. Yeah, I was just mentioning that in that case, basically, when you are doing dump or store, then only it will be converted into Mapreduce and then executed, right? So that is why there is no need of creating or loading all this data in physically somewhere. Only it is like in memory. In fact, data will not be there at all. It's just the steps. The steps are remembered in the memory by pig. Only when you execute dump or store, it will convert all the steps in Mapreduce and then execute it. So Nikhil, as I said, you can do it if you want to read more than one row. Illustrate will always give you one row. Okay? I mean one row in the sense sample set of data. Yes, Ram. Can you hear me now? Okay. So Raj, by the way, I explained your question. So are you clear with that? Okay, let me repeat. So basically your question was, does it store it in memory? So the answer is no, it doesn't store all this data in memory. It just keeps the metadata information about these steps, that how to execute these steps. And when you actually execute dump or store command, then only it will create a MapReduce. It will do this query plan, execution, creation of the MapReduce program, and then execute it on the Hadoop cluster to process your data and give you the result back, right? So all these steps that will be performed are by converting, MapReduce programs and executing everything as a one MapReduce program. But till that point, till you execute dump or store command, none of the statements are really executed. They are just stored in the memory, and they are basically just it's kind of like metadata information which is kept there with pig engine. It doesn't execute them. Is that clear? That is internal, Olga. Just leave it. No need to worry about that part. Good point, Mary. If you come out of this, let me come out of the pig shell. Okay. Now, if you again log in back to the pig, will the Indian custom USA data will be there? Let us check it out. Okay. So here, if I do this, illustrate USA, can you see this, Mary? You are getting an exception. It says did not find the physical plan for this, which means it doesn't remember that. Now your metadata is flushed out when you quit. So it doesn't remember what is alias. It says unable to find an operator for alias USA. Is that clear? Okay, so what it means is you have to first create that two steps again because it has flushed out that data from the memory if you quit from the grunt shell. Now if you do illustrate USA, I should get all the data correctly. Okay, fine. So everyone clear as of now? Any more questions anybody has? Okay, so now we have loaded both the files. Now what we need to do, we need to merge these files. So what I will do, I'll just say total customer is equals to union India, comma USA. Simple. If I want to merge two files, I just use union word because the structure of these two tables are same. Now if I do illustrate total customer, you can see how beautifully it will give us the result. If you do illustrate total customer, it will shape this way. It has taken one record from India, one record from USA, and this is how it has combined both the users. Okay. So this is how you do unioning of the tables. Is that clear? No, 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 Mary. I'm just showing it because you can easily understand. That's why. Okay. Now, once you have a total customer, what do you need to do? After that, simple, you just need to split. Split, see, in pig, that's what I said that 10 lines of pig is 100 lines of Java because a lot of inbuilt operators are available. So let's say I want to split total customer table into two reports based on the condition that whichever customer has more than 5 as a score, he should be put in the one table and other customer should be put in another table. So you can achieve this functionality in one line. You just say split total customer into good customer if score is greater than 5. Bad customer otherwise. Okay. Split total customer into good customer. It's one more table where you put all the records which has credit score more than 5. Otherwise, put it in the bad customer. The idea here is basically okay. So let me execute this and then I'll execute a dump command. I'll just say dump, let's say good customer, or let me just dump bad customer, which has your record. So when I do that, it's C capital. If I do this, it will now execute it as a Mapreduce. It is actually executing it as a Mapreduce and then give you the data. So as you can see, you get these 3 records. All right. Is that clear, everyone? So I got all the customers who have credit score less than 5. That is what I got it here. This is what we mean by dump. Now, you can also store the output. Let me do that. You can say store bad customer or good customer into, and you can give a path. Am I audible, everyone? Hello. Okay. Yeah. So what I was saying is, did you understand that script that we have just written? Okay. See, what I have done is, you know all the split command, right? Did you understand split command? Everyone, did you understand split command? Yes. So after split command, I have directly used the store command, right? To store into some output file. Let's say I'm doing this. I want to store it into this one location. So just I executed a store command. It will say success. Okay. What was the store command used? This is the one. Store good customer into actual file path. Okay. So basically, if you go to the in the local file system, if you go to see customer one, see multiple parts of edit, and again customers with queries for more than 5. So that is what you can see it here. All right. And how does this store command work? Any questions anybody has? Yes, Raj, that is true. Hello everyone, am I audible? Yeah. Okay, fine, great. So yeah, I was just saying that basically, see, this was the. So by the way, tell me one thing. Did you understand this problem that we have just discussed? I have executed the store command and then I showed you that output in the local file system. Right? Were you able to follow that? So Mano, where did you not follow? Like which point you followed and after that you got stuck? Because others say they are able to follow. That's why I'm just asking like from which point you are not able to follow. I can't explain each and every steps again. I'm really sorry for that. But then if you can just let me know which step you understood, then I can explain from that step. No, no, it didn't. Others were able to follow, but let me just quickly repeat. So what we have done, see, we have loaded the file in the customer and India, and I'm sure all of you know that. Then we did union on these two data. So we combined both the files into the same table, and then we just split that table into good and bad customer based on some condition, is score greater than 5 or less than 5. And then we just say dump or let's say if you just do dump bad customer, what it does, it will just print the data on the console itself, right? Same way we have executed the store command. So this is how you execute one pig script. Okay, got it. So that completes one pig script. Let me also take one more example on a pig script and we will understand about it. So let's say I have a file. No worry, I have not saved the script. You are right, yes. There is a way to save the script. I'll show how do you execute everything as a script. Right? So it's a small request to everyone. Whenever you ask, and if I answer, yeah. Hello everyone. Hello everyone. Am I audible? Hey guys, I need to inform you that I think there is a serious network fluctuation happening in the area where I'm staying. It's in Bangalore, and I'm sure many of you who are in Bangalore can understand this because there is a lot of power outages happening and a lot of network fluctuation is happening. So unfortunately, last 5-10 minutes, I think it is happening, and that's why we are not able to. You guys are not able to hear my voice. What we can do is instead of starting a new topic, I think we need to close the session here, and because I don't want you to kind of be in that flux, whether you are able to hear that or not. Right? Let me just check with them like what is happening, and then probably we can start fresh from tomorrow. Is that fine with everyone? Yeah, I'm really sorry guys, this is not under my control. Unfortunately, there is a lot of network outage that happened in my area today. I just got to know that, so a lot of people are facing this issue. Uh, Bangalore has a very bad infrastructure. No one can deny that. No, we don't need to do that, Olga. It's okay. We can leave it.